So we've picked u in example 1 as x squared plus 1. Now I'm going to take the derivative of u, just writing that down to remind us what du is all about. The derivative of the u expression. So in this case, the derivative of my u expression is 2x. And I'll throw the extra dx on for the substitution plan to work. Okay. Now I check it out to see how things are working. There's u, just like I have it. So this is going to feel pretty good so far. When I start looking for du stuff, oops. When I start looking for du stuff, make it pink. X dx looks good. But I gotta have what's in my du in my work. So I need a 2 to make everything work. So I'm gonna throw a 2 in the problem. And you'll see I do this a couple different ways. I'll throw the 1/2 down as well. So when I go to rewrite this, I'm actually gonna put the 1/2 in the front. I'll have u squared. Everybody else became a part of the du. So this 2, oops, I'm doing pink for du. This 2 went into du. So pinks went into du, the green went into u, and the 1/2 came along for the ride. Now, extra substitution portion. This integral has 0 and 2 for a and b. That 0 and that 2 are part of the integral when it was an x integral. So these are x values. I need to change them into the correct values when I write this problem for u instead of x. So an x of 0 is going to become a different u number. This 2, which is an x number, is going to have to become a different u number. And I'm going to use what I chose and said u was going to represent x squared minus 1. So 0 squared, oh excuse me, x squared plus 1. 0 squared plus 1 is going to be 1. That's going to be the new a value. And 2 squared plus 1, or 5, is going to be the new b value. So I'm going to come over here. I'm going to put the 1/2 down. I'm going to put the u squared du down. But watch out, top and bottom of my integral, a 1 and a 5. Everything has to change. If I'm going to write the problem in u format, all the numbers have to match that format. So the 0 and the 2 had to change. The way they change will depend on the problem. It will always be using whatever your u is as a formula. I get new u's by taking old x's and squaring them and adding 1. One of the goofy math things like calculus teachers say about this to kind of remember is sort of when you do u substitution, it's like changing an outfit. You're doing a makeover and changing their outfit. And the 1 and the 5, these are like changing the shoes to match the outfit. You got to change everything here, and you got to change those as well so everything matches. Okay. That's one way to, it's an analogy to help you think about it. Okay. That's probably one of the most common mistakes when students are doing U substitution and fundamental theorem is you do all this work, but you forget about switching these guys to different numbers. Okay. Now, everything is in terms of U. We're going to integrate. We're going to find the big F function. Now, I have to be careful about this. It's the big F function in terms of U. It's F of U. I'm always going to say that of in there. F of U, okay, instead of F of X. It's big F, because remember, fundamental theorem, we take big F of B minus big F of A. I need to find big F. I need to find my antiderivative. So, antiderivative. Antiderivative of U squared is U cubed over 3. Backward power rule to run the antiderivative. With the extra 1/2 I needed because of the U substitution. Normally, I would write down plus C. I would switch U's over to X's. I'm not doing either of those things this time. This is my big F of U. So I'm going to do big F of 5 and big F of 1. Because that's what you do in an antiderivative fundamental theorem problem is you plug stuff into the antiderivative. So my numbers to plug in are 5 and 1. This is 125 over 6, and this is 1 over 6. I'm just doing these by hand because it's easier for me than grabbing the calculator. Plus, this is the third time I've done these. And then I subtract. Remember, this was B and that was A, so I got to take F of B minus F of A. So 125 over 6 minus 1 over 6. I'm going to come up here. Final answer, 124 over 6, or I think it's 20.6 repeating. Okay. I have almost all the quizzes graded, and most of you are doing great on the fundamental theorem problems, the two in the middle. Finding the antiderivative and plugging in B and plugging in A and subtracting. The mistake I'm seeing on some of them is subtracting in the wrong order. So that's why I always kind of try to make sure I do B first and A second, and then do F of B minus F of A. Kind of helps me remember this number minus this number. You're going to be way off if you do this with 0 and 2. You will not be getting the right numbers. That's why we got to make sure we show the substitution in the integral, and so that way I can see substitution for U, substitution for U, substitution for U. All the substitutions done. Now we just attack it. Really, after we've written the problem here in red, everything that happens after that is fundamental theorem that you know that you've been doing. Nothing new once the problem's rewritten. Rewriting it's a whole another mess, but once we get it rewritten, take the antiderivative, apply fundamental theorem, and get your value answer. There isn't anything else that's a catch, really. The U substitutions can vary, but we've looked at a couple different options, and we're going to look at a couple more of those types. Negative exponents, fraction exponents, weirdness with the numbers, those are the things that sometimes make the U sub hurt. The fundamental theorem part of it, though, there really isn't anything tricky, extra tricky about it, because once you get this into U form, as long as you've changed these numbers and you remember to do the antiderivative, nothing over here is new stuff. All right, I'm going to stop that.